We can also use the work energy principle for systems instead of just for a single particle. So we set up our same work energy principle equation where we have initial kinetic energy plus all of this work is equal to the final kinetic energy. And in this case, instead of having just one kinetic energy, we have multiple ones because we're doing a system. So we'll have the sum of the kinetic energy and the sum of the kinetic energy terms, but we'll still have all of the work. Usually we use this for things like pulley systems where they're really interconnected by this rope, and that's really convenient because the work done by tension is equal and opposite on the different objects. So for example, here I have a pulley system where I have 5 pulleys that are A is on one side and B is on the other side. So in this case we'd have something like 1/2 MA VA1 squared plus 1/2 MB VB1 squared. And then we have all of the work. And in this case, there's work done by gravity. So this might be, or this would be something like MA G delta HA plus MB G delta HB. And then there's also work done by tension. So in this case, we'll have on block A, we'll have 1 tension times the change in position of A, and on block B we have 1, 2, 3, 4, 5 tensions times the change in height of B, and all of that will equal to the sum of the final kinetic energies. So 1/2 MA VA2 squared plus 1/2 MB VB2 squared. And we'll need all of those terms, but in fact these 2 tension terms will cancel out. And that is because if you write the length of the rope equation for this system, what you'll find is that delta HA will be 5 times and in the opposite direction of delta HB. And so those 2 terms are actually equal and opposite, and they'll cancel out. And that will be true in every single pulley system. And so every single pulley system, the work done by tension will cancel out. We don't have to worry about it. And what we'll be left with is just the kinetic energies of the blocks at the beginning and the end. And in the case of pulley systems, the gravitational potential, the work done by gravity. So the mg delta h's. So this is really nice for systems, a little bit different where we're doing the sums of the kinetic energies instead of just a single kinetic energy.